Envision an epic get-together played by a ceaseless number of stars, planets, and moons all playing together wonderfully. Regardless, there is one unequivocal section of the symphony that has shocked space experts for a truly long time. Exoplanets are standard planets that exist outside our planetary framework, stowed away somewhere deep in the Milky Way. You might be dumbfounded to find that among the gigantic number of cosmic objects there are exoplanets so like Earth, so tantalizingly similar yet confusing that they may be our planet. Sublime twin. We dive into the fascinating area Proxima B, found 4.2 light years away. The James Webb Space Telescope is revolutionizing our journey to understand these celestial secrets. Envision a moment when your mind journeys across the vast cosmic realm of our existence, the Milky Way, which is home to more than a quadrillion exoplanets. That's a number with 15 zeros. To put this number in perspective, if each of these planets were the size of a grain of sand, we wouldn't just fill the Grand Canyon, we would have enough to create another landmark on Earth, a Grand Canyon 2.0 that would stretch for an immense distance. It's astounding that around 20% of these magnificent bodies have been classified as Earth-like in terms of geography and atmospheric structure. That means there's a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons rugged satellites like our moon caught in gravitational dances with their parent planets. If you've ever considered the possibility of finding another body in space that harbors life or could support it, the universe offers an endless stream of opportunities. Now that we've laid out this majestic scale, it's time to introduce the masterful artisan poised to paint its intricate details. The James Webb Space Telescope, this extraordinary Sherlock Holmes with its enhanced lenses and adaptable focal center, surpasses even the most advanced optical instruments. We're not talking about any ordinary lens. It boasts a 6.5 m primary mirror, 2.7 times larger than Hubble's. Imagine the detail it can capture even in the faintest glow of a star billions of light years away. At that distance, it can also study the intricacies of orbiting planets. What makes the James Webb Telescope revolutionary isn't just its seeing power, but also its advanced technology, including sophisticated sensors and spectrographs. These instruments can do far more than simply observe. They analyze the unique light emitted or reflected by celestial objects to determine their chemical composition, density, and even mass. Acting as a space detective, it can identify whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope elevates our capabilities from simple observation to profound discovery. Of Hubble's revelations amaze you, prepare for a genuine cascade decade of groundbreaking discoveries as we broaden our gaze across the intricate landscape of the universe. One star commands special attention in the celestial symphony, Proxima B. Since its discovery in 2016, this enigmatic planet has captivated astronomers and anthropologists alike, much like a Shakespearean character, brimming with complexity and intrigue. So, what's all the fuss about? First, Proxima B is practically in our cosmic neighborhood, just 4.2 light years from Earth. To put it in context, if you could break the universal speed limit and travel at the speed of light, you would arrive in just over 4 years, about the same time it takes for your favorite TV show to return to reruns. But let's delve deeper into why this proximity is so significant. We're talking about a universe that spans over 93 billion light years from end to end. Finding a planet so close and accessible for scientific investigation is like spotting a pearl in a mountain-sized haystack a pearl that potentially holds secrets about life itself. Proxima B isn't just notable for its closeness to Earth, but also for compelling signs that it might be Earth-like, possibly even Earth 2.0. It orbits within the habitable zone of its parent star, where conditions are neither too hot nor too cold, just right for liquid water to exist. Imagine fountains, wandering streams, vast lakes, and maybe oceans as deep and mysterious as the Mariana Trench. Before we start dreaming about vacations on Proxima B, let's consider some of its characteristics. A single day on this fascinating exoplanet lasts a staggering 11 Earth days. Imagine sunrises that usher in a new day, stretching slowly into long afternoons, followed by lingering sunsets. While this might sound idyllic, it has major implications for the planet's climate and habitability. How would human biorhythms adapt to such prolonged cycles of light and dark? Would we eat 3 or 4 times more in a single day? Would we sleep differently? The fundamental patterns of life as we know them would be both tantalizingly familiar and frustratingly alien. You might wonder how we can gather precise data about a world we've never visited. The James Webb Telescope deploys all its capabilities like a colossal Swiss army knife. It's more than a telescope, it's a state-of-the-art research lab in the vacuum of space. Using advanced spectrographs, the telescope can analyze the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at specific frequencies. By focusing on these patterns, researchers can perform a remote biopsy of celestial bodies, determining atmospheric pressure, density, and even the presence of life. Essential compounds like water, organic carbon molecules, and oxygen. Astrobiology is not just stargazing, it's space forensics. The James Webb Telescope isn't merely an eye in the sky, it's an exquisitely specialized lab, a detective and a master scientist rolled into one. It transforms speculation into testable hypotheses, reshaping our understanding of what could exist beyond our blue. Just when you thought you'd uncover the most astonishing layers of this cosmic onion, the story veers in an unexpected direction, much like a science fiction thriller. Using the James Webb Telescope, scientists detected something extraordinary from Proxima B, an electromagnetic signal so intricate and puzzling that it hinted at the possibility of an advanced civilization. Dubbed a potential techno-signature, this signal sent shock waves through academic circles and social media. Could this be the confirmation we've been seeking, that we are not alone in the universe? Just as quickly as it appeared, the signal vanished, leaving behind a profound silence and a maze of unanswered questions. Was it merely a fleeting cosmic anomaly, a serendipitous alignment of universal forces, or something deliberate, a coded message, a sign of extraterrestrial intelligence? The discovery ignited fierce debates and theories, leaving us with more questions than answers. But the story of our grand exploration is far from over. This is not the end, it's a new beginning. Scientists are now planning to push the James Webb Telescope even further, transforming it into a kind of cosmic night vision device to hunt for artificial light sources in both the dark and illuminated regions of space. These artificial light sources, potential indicators of advanced civilizations, could be faint glimmers of cities or industrial activity on distant planets. By searching for these subtle engineered lights, astronomers hope to uncover evidence of technology that mirrors or perhaps surpasses our own. Imagine spotting the faint glow of a distant metropolis billions of miles away, twinkling in the void of space. This ambitious goal is not without its challenges. The search for techno signatures demands precision beyond anything we've achieved before. It requires filtering out the overwhelming noise of natural cosmic phenomena stars, supernova and the countless celestial objects that populate the universe even. The faintest signal of artificial origin would have to stand out amid this cacophony like a whisper in a roaring crowd, yet the stakes are monumental. If successful, it would mean we are not alone in the universe, that another civilization, perhaps far older and wiser, has left its mark for us to find. The implications of such a discovery would ripple through every facet of human existence, reshaping philosophy, religion, and our understanding of our place in the cosmos. The pursuit of life beyond Earth also raises profound ethical questions. If we find evidence of intelligent life, what should our next step be? Should we attempt to communicate? Could we inadvertently reveal our presence to beings who might not have our best interests at heart? These questions weigh heavily on the minds of scientists and ethicists alike, reminding us that exploration is not just a scientific endeavor, but a deeply human one. As the James Webb Space Telescope continues its work, it serves as a symbol of human curiosity and ingenuity. Its discoveries remind us that the universe is vast, mysterious, and full of potential. Proxima B and its tantalizing secrets are just the beginning. With every new exoplanet discovered, every new spectrum analyzed, and every faint signal detected, we move closer to understanding the ultimate question: are we alone? Perhaps one day the answer will come, not in the form of distant whispers, but as a clear and unmistakable call from the stars. Until then, humanity will keep looking, questioning, and dreaming, fueled by the knowledge that the universe is far greater and more wondrous than we could ever imagine. Far off universes, we're taking a gander at stunning possibilities, such as the potential for distinguishing artificial versions of cities glowing in the dark like brilliant SPS. Imagine seeing the shimmering light emissions. Could it be a city humming with the presence of an advanced civilization, radiating its glow into the vast, immense cosmos? As we continue to unravel the mysteries of the universe, the endeavor for extraterrestrial life takes on new perspectives beyond the immediate interest in Proxima B. Our extraordinary quest delves deeper into the expansive regions of space. This pursuit is driven by both technological advancements and a profound curiosity about our place in the universe. Ceaseless leaps forward in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, JWST biomarkers, and ground-based observatories have expanded our ability to detect and study these distant worlds. One particularly captivating area of study is the search for biosignatures, indications of life. These signs could include atmospheric gases like methane or carbon dioxide, which under the right conditions could suggest biological processes. The JWST capabilities extend beyond basic detection. Its advanced instruments can measure the atmospheric composition of exoplanets with remarkable precision. By studying stearite that filters through an exoplanet's atmosphere, scientists can identify chemical markers indicative of life. For example, the presence of water vapor along with other key molecules like oxygen or ozone could highlight the potential for life-supporting conditions. Another avenue of exploration involves studying the conditions of these far-off worlds. Environmental models based on data from the JWST can help predict whether an exoplanet's conditions could support liquid water. This is crucial, since water is considered a vital component for life as we know it. Scientists are particularly interested in planets located in the habitable zone of their parent stars, where temperatures could allow stable liquid water. The search also extends to the moons of exoplanets. Some of these moons especially those in the habitable zones of their host planets, could harbor conditions conducive to life. For instance, icy moons in our solar system, like Europa and Enceladus, are thought to contain subsurface oceans beneath their frozen crusts. Similarly, moons orbiting exoplanets might harbor conditions where life could exist. The concept of technos signatures has also gained traction. These indicate advanced civilizations that might be detectable through artificial structures or technologies. This could include superstructures like Dyson spheres, hypothetical constructs designed to capture a star's energy, or unusual patterns in radio transmissions. As we refine our global collaborations and observational techniques, the search for technosignatures could reveal the presence of extraterrestrial intelligence. In addition to technological advancements, global cooperation plays a pivotal role in the quest for extraterrestrial life. Collaborations between space agencies, research institutions, and private companies enhance our ability to explore space. For example, missions to Mars and other celestial bodies involve contributions from multiple countries, pooling resources and expertise to achieve shared goals. Public engagement and education are also critical aspects of this mission. The excitement surrounding space exploration inspires the next generation of scientists and engineers. Outreach programs and educational initiatives foster an interest in STEM fields and encourage young minds to pursue careers in space science. The development of new technologies also deepens our understanding of the universe. Advances in telescope design, data processing, and computational models enhance our ability to detect and study distant exoplanets. For instance, cutting-edge space telescopes like the planned Extremely Large Telescope ELT and the Habitable Exoplanet Observatory HABEX are set to provide even more detailed views and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each new discovery raises new questions and areas for exploration. The search for extraterrestrial life isn't just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our understanding and broadens our perspective on what it means to exist as a species. The study of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each step we edge closer to answering some of the most profound questions humanity has ever posed. As we continue to explore the universe, the opportunities for discovering new forms of life and understanding our place in the cosmos remain boundless. Humanity's exploration of exoplanets continues to captivate the imagination of scientists and the general public alike. These far-off worlds, once thought to be inaccessible, have now become key focuses in the search for life beyond Earth. One of the most promising aspects of exoplanet research is the discovery of planets located in the habitable zones of their stars. This zone, often referred to as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist, a prerequisite for life as we know it. The study of exoplanets in the habitable zone offers a glimpse into the potential for life on worlds far from our own. But beyond water, scientists are also investigating the atmospheric compositions of these planets, searching for markers that could indicate biological activity. The presence of certain gases, such as methane or oxygen, in a planet's atmosphere could point to life processes. The James Webb Space Telescope's ability to analyze exoplanet atmospheres with unprecedented precision makes it an essential tool for this research, enabling scientists to detect even the faintest traces of gases that could suggest the presence of life. Additionally, the search for moons Orbiting these exoplanets adds another layer of intrigue. Many moons, especially those orbiting gas giants, could harbor environmental conditions where life could thrive. Moons such as Europa and Enceladus in our solar system have been hypothesized to have subsurface oceans, making them prime candidates for the search for life beyond Earth. Exoplanet moons could follow a similar pattern, with liquid water existing beneath icy surfaces, providing a potential habitat. As for life, technological advancements in both space exploration and instrumentation are driving this quest forward. Instruments like the extremely large telescope ELT and the Habitable Exoplanet Observatory HABEX are poised to offer even greater insights into the potential for life on distant worlds. These instruments, along with international collaborations, promise to unveil more answers to questions that have captivated humanity for centuries. Are we truly alone in the universe as we continue to make breakthroughs in this exciting field? The possibility of discovering extraterrestrial life becomes ever more tangible.